Hello and welcome to today's session on the Pythagorean theorem. Make sure you take notes as you go through this presentation, as you will want to use them to help you answer the asynchronous questions. So what is the Pythagorean theorem? To introduce you to this topic, allow me to present the NFL.
It's one of the most exciting chases in the NFL. A receiver or running back making a beeline for the end zone with a defender in hot pursuit.
You identify the ball carrier. From there, you want to close the distance between yourself and the ball carrier as quickly as possible.
They have to choose what direction and speed to run so that they get to the same place at the same time as the runner and can make the tackle.
In football, the path the defender must take to intercept the ball carrier is called the angle of pursuit. According to John Zeigert, an automotive engineer at Clemson University, this path is also a perfect illustration of a fundamental equation in geometry called the Pythagorean theorem, discovered by the Greek mathematician Pythagoras more than 1,700 years ago.
Pythagorean theorem is a basic theorem in plane geometry or Euclidean geometry that relates the lengths of the sides of any triangle where one of the angles is 90 degrees, called a right triangle.
On a right triangle, the two adjacent sides, A and B, are called the legs. The longer side, opposite the right angle, C, is called the hypotenuse. The Pythagorean theorem simply states a squared plus b squared equals c squared.
The square of the hypotenuse, the length of the hypotenuse, is equal to the sum of the squares of the lengths of the other two sides.
Relating this to football, let's say the ball carrier is heading for the end zone 40 yards away. The defender stands 30 yards away and needs to intercept him. If these two distances are the legs of a right triangle, then the distance the defender needs to run is the hypotenuse. Using the Pythagorean theorem, 30 yards times 30 yards added to 40 yards times 40 yards will give the length of a hypotenuse squared. To get the actual length, take the square root.
40 squared plus 30 squared is equal to 2,500, which is 50 squared. So the distance of the hypotenuse is 50 yards.
You got to be precise in what you're doing, and you have to take the right angle, especially in coverage.
NFL players must react instinctively to cover this distance and also gauge how fast they need to run to match their opponent's speed.
The defender, now, if he chooses that angle of pursuit, he says, okay, I've got to cover this distance in the same amount of time it takes the runner to cover this distance.
If you're chasing a fast guy, like a Marshall Faulk or some of those guys that can really burn, if you take the wrong angle, you're done.
The defender's angle of pursuit can be the difference between a touchdown and a game-saving tackle. It's also a perfect illustration of the properties of a right triangle and the ABCs of the Pythagorean theorem.
Alright, so let's talk about the Pythagorean theorem in some key terms. So as you saw from the video, the legs of a right triangle are the two shorter sides of the triangle that make up the right angle. So in this case, both of these sides here are legs. The hypotenuse is the longest side of a right triangle. It's the side that's always across from the right angle. So in this case, this side of this triangle is called the hypotenuse. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the square of the other two sides, or the other two legs, as you heard in that video. But we'll talk about how to use that to solve problems using the Pythagorean theorem. The Pythagorean theorem is simply written as a squared plus b squared equals c squared, where A and B are the legs of the right triangle, and it doesn't really matter what side I call A and B as long as they're both legs, and C is the hypotenuse of the triangle. So in this equation, the C has to be the longest side of the triangle, what we refer to as the hypotenuse. A Pythagorean triple. Okay, a Pythagorean triple is a set of three positive integers, a, b, and c, that satisfy our equation a squared plus b squared equals c squared. The idea that all three numbers have to be positive integers or whole numbers. All right, so an example of a Pythagorean triple is 3, 4, and 5. This would be a triangle that has legs of 3 and 4 and a hypotenuse of 5. Another Pythagorean triple is 5, 12, and 13, where 5 and 12 would be the legs of a right triangle and 13 is the hypotenuse. 7, 24, and 25 is another example, as well as 8, 15, and 17. These are called Pythagorean triples because 3 squared plus 4 squared would equal 5 squared in this example. So what do I mean? Well, let's do an example and find out. Let's find the length of the hypotenuse of this right triangle and then determine whether it is a Pythagorean triple. So suppose I have a triangle with side lengths, or the lengths of the legs being 6 and 8. Well, I'm going to start off with my Pythagorean equation, which is a squared plus b squared equals c squared. And for the legs, I'm going to plug in 6 and 8. Remember, I can plug in 6 for the a or 6 for the b. It doesn't matter because it's a leg, as long as I'm plugging in the legs for a and b and leaving the c as the longest side, the hypotenuse, which is the unknown in this case. We can see that we're missing the hypotenuse because this side here is across from the right angle. It's not making up that right angle. So I simplify the left-hand side of this equation. I get that 36 plus 64 is equal to c squared. I simplify the left hand further to 100, so I get that 100 is equal to c squared. And we're not done yet. We don't want to know what c squared is, we just want to know what c is. So we have to undo raising to the second power, and the opposite of squaring something is taking its square root. So to get from this 100 to 10, I took the square root of 100. And the square root of 100 is 10, because 10 times 10 is 100. So now let's consider the original question. Do these side lengths form a Pythagorean triple? Well, the hypotenuse is 10 units. So do the sides form a Pythagorean triple? Yes, because all the numbers are positive integers. They are 6, 8, and 10. So let's find the length of the hypotenuse of the right triangle. First, I determine what's been given to me. To use this equation, you basically have to be given 2 of the 3 sides, and then you can always solve for the missing side. And in this case, I'm given the 2 legs again. Again, the way that I know that is the longest side, right, that's the hypotenuse, is across from the right angle. So I plug them into my equation, so I get that 7 squared plus 8 squared is equal to c squared. We simplify the left-hand side. Remember, this means 7 times 7, not 7 times 2, right? And 7 times 7, or 7 squared, is 49. 8 times 8, or 8 squared, is 64. We continue to simplify the left-hand side of this equation, and we get that 113 is equal to c squared. Finally, we don't want to know what c squared is, right? We want to know what c is. So in order to find c, we take the square root of both sides. And if ever you forget that last step, all you have to do is think about your answer and look at the triangle that you've been given. For example, if I stopped here, if I stopped at step 3, where I had 113 is equal to c squared, and perhaps I thought 113 was my answer, just look at the picture. If this side length is 7 and this side length is 8, does it make sense that this side length is 113? That would be way too big. Now, since it is the hypotenuse, it is the largest side, so I know it's got to be bigger than 8, but 113 is unreasonable. All right, so in this case, the last step is to take the square root of 113, And if you punch the square root of 113 on your calculator, you'd get a number that was larger than 10 but less than 11, so 10 point something something. In this case, I just leave my answer exact as the square root of 13. Consider example 2. Again, we can see in this case that we've been given the legs. Alright, so I'm being given two sides of this triangle, and I'm asked to figure out the third. The third side is the hypotenuse again, so remember it's the c in our equation, a squared plus b squared equals c squared. And I kind of like to start off writing that. So I'll write off a squared plus b squared equals c squared. Then I'll go about asking myself what was given to me, the a and the b, or an a and a c. In this case, I've been given the legs, so the a and the b. Then I plug them into our equation. So I get that 12 squared plus 16 squared is equal to c squared. We simplify the left-hand side of the equation. And remember, this means 12 to the second power, or 12 times 12, and that's 144. 16 squared is 256. I add 144 and 256 to get 400, and 400 is equal to the hypotenuse squared, or c squared. So then finally I take the square root of both sides to figure out the length of the hypotenuse, and in this case it is 20. So here's another example where I'm finding the hypotenuse. So I've been given the legs again of 5 and 12. So that 5 squared plus 12 squared is equal to c squared. 25 plus 144 is equal to c squared, and so then the square of the hypotenuse is equal to 169. So I take the square root of both sides and I get that the hypotenuse is 13. So now, do any of these triangles form a Pythagorean triple? Well, let's look at example 1. In example 1, the legs are 7 and 8, and the length of the hypotenuse turned out to be the square root of 113. The square root of 113 is not a whole number. Remember, it's 10 point something something as a decimal. In example number 2, we have the legs of 12 and 16, and we discovered that the hypotenuse was 20. So in that case, since they're all whole numbers, or all positive integers, number 2 is a Pythagorean triple. In example 3, we have legs of 5, 12, and we've discovered that the length of the hypotenuse is 13. Again, they're all positive integers, so therefore number 3 is a Pythagorean triple. Now let's find the length of a leg given the length of one of the legs in the hypotenuse. So it doesn't matter if I know this leg in the hypotenuse or if I know the other leg in the triangle in the hypotenuse, we solve it the exact same way. And I always start by writing my equation a squared plus b squared equals c squared. And if it helps you, you can go ahead and label those sides on the triangle in the same way. As long as I label the legs a and b. So like this would be a, this side would be b, and remember I have to call the longest side, the side across from the right angle, c. That has to be the hypotenuse. So now look that I replaced the a with x squared, because that's how it was labeled in this triangle. So that's where this x came from. Then I went ahead and I replaced b with its value of 9 in the Pythagorean equation. And then we saw that the hypotenuse is the c. In this case it's 12, so I replaced the c in our equation with 12. Now I can go about solving this equation. Alright, so let's go ahead and solve it using inverse operations. Alright, in this case I'm going to go ahead and simplify the squares. So I'm going to go ahead and go 9 squared is 81 and 12 to the second power is 144. Then after that I need to get the x term all by itself. So right now the x is with this positive 81 on the left hand side of this equation. So I need to undo addition with subtraction. So I subtract 81 from both sides. So to get from step 2 to step 3 here, I subtracted 81 from both sides. So on the left hand side that left me with just x squared. And on the right-hand side, I went 144 minus 81, and I got 63. And then finally, remember, we don't want to know what x squared is. We don't want to know what the length of the side squared is. We just want the length. So to get that value of x by itself, we have to take the square root of both sides. So now if you go ahead and you punch the square root of 63 on your calculator, you would get a decimal. So to leave my answer exact, I just leave it as a square root. In this case, a square root of 63. Let's find out what the square root of 63 actually is. Well, I know that the square root of 64 is 8, because 8 times 8 is 64. So this number here is a little bit less than 8. So it's like 7 point something something something. So I know that it's a decimal. All right, and the value of 7 point something 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 is less than 12. So that makes sense in this scenario because remember our longest side is the hypotenuse, and it has to be longer than the leg. So if ever you get an answer for one of your legs as being longer than the hypotenuse, then you know that you did something wrong. So next question, do these side lengths then form a Pythagorean triple? Well, the answer is no, because the length of this leg is the square root of 63, and as we already saw, the square root of 63 is not a positive integer. Alright, so let's find the length of the missing side here. So again, I'm giving one of the legs and the hypotenuse, and we're asked to find the length of the other leg. So we set up our equation, a squared plus b squared equals c squared. I go ahead and simplify by squaring the numbers. So in this case, 21 times 21 was 441, and 24 times 24 was 576. Then I get the x squared term, or the variable term, by itself. So in this case, I need to subtract 441 from both sides of the equation. And I get that 576 minus 441 was 135. So that's where this 135 came from. And then finally, we don't want to know what x squared is, right? We would just want to know what x is. So I take the square root of both sides. And I would go ahead and I'd punch the square root of 135 on my calculator. And I'd see that it said 11 point something 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 something. So then I just leave my answer as radical 135. Either that, or sometimes the question may ask you to simplify and round to one or two place values. If it does that, then go ahead and get that decimal value and round it. But in this case, I'm just going to leave my answer exact. So let's consider another example. Again, I'm given the hypotenuse in one of the legs and asked to find the value of the other leg. Notice in this scenario, I have one of the legs as being the square root of 7. So what do we do with that? All right, well, still I'm going to write out my equation, a squared plus b squared equals c squared. And then notice that the missing side, I'm just going to call that x. So x squared plus, in this case, the square root of 7 squared. So I'm squaring the square root of 7. Another way to write that would be like this. So I am squaring the square root of 7, and that equals to 4 squared. So let's see what happens when I square the square root of 7. In this case, we can see that I just got 7. And there's two ways to think about it. One is that taking the square root of something and raising something to the second power, or squaring, are inverse operations, and they cancel each other out, leaving you just what's underneath the radical. Another way to think about it is that the square root of 7 times another square root of 7, because that's what the square root of 7 squared would mean, right? I would times it by its own self. That would equal to the square root of 49, and the square root of 49 is 7. So we get back to where we started. So finally we get that x squared plus 7 squared is equal to 16. And then I solve that using inverse operations. So I'm going to subtract 6 from both sides of the 7, from both sides of the equation, and get that x squared is equal to 9. And then we take the square root of both sides, so we figure out that the side length on this missing leg here is 3. And again, I like to kind of check and make sure that makes sense to me. Well, the length of a hypotenuse is 4, and remember it has to be the longest side. So having a leg of length 3 is a possibility. It makes sense, and it looks like it's about right in this equation. So I feel pretty confident about that answer. Let's try one more example. So I want you to take a moment to pause the video and see if you can figure out the length of the missing leg. Go ahead and round your answer this time to 1 decimal place. Alright, so I set up my Pythagorean equation. I get that x squared plus 5 squared is equal to 7.1 squared. So where there was an a in the original Pythagorean theorem, we know we just label that side x in this case because it's an unknown missing leg. And then the 5 was the other leg. And the 7.1, the side that's the number that's by itself on the other side of the equal sign, remember that's the hypotenuse. So we go about simplifying this. So we get that x squared plus 25 is equal to 50.41. And the step to get from step 2 to 3 here was to subtract the 25 from both sides. So that left me with 25.41. And then finally I would take the square root of both sides and be left with the decimal 5.04. If I were asked to round to 1 decimal place, I would write 5.0 because 4 is less than 5. If I were asked to leave it as an exact decimal rounded to, in this case, 2 decimal places, I would leave it as 5.04. So do any of these sides form a Pythagorean triple? Well, in example 4, the square root of 35 is not a positive integer, so that is not a Pythagorean triple. In example number 5, even though the answer we got for the leg that we were looking at is an integer, it's the integer 3, we can see that the hypotenuse is length 4, however, the other leg is the square root of 7, and the square root of 7 is not an integer. So this is not a Pythagorean triple. And then in the last example, we have in fact 2 different sides that are integers. This leg is 5.04, which is a decimal, and this leg is 7.1, which is a decimal. So in this case, none of these are Pythagorean triples. So here's your exit ticket, right? You need to go to the Asynchronous Session 4 questions. To find them, you need to go to your course announcements, find the Asynchronous Session 4 announcement, click on the questions link, and answer the Google form and click submit when finished.